Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 179. 179, the very last problem in the first column, number 192. Problem number 192. Let's take a look at it. Today is our lesson number 219. In 192, they tell us for all values of x for which which of the following describes all values of x for which this part is true. 1 minus x squared is greater than or equal to 0. 1 minus x squared is greater than or equal to 0, and the question is what values of x would hold this thing true. Let's add x squared to both sides. So here this drops out and we end up with 1 is greater than or equal to x squared. 1 is greater than or equal to x squared is a very awkward way of saying that x squared is less than or equal to 1. X squared is less than or equal to 1. Now what we have to understand here is what does it mean? How do we show it on a number line? If we have to show it on a number line, yesterday we used this word verbatim and I was going to cover it and I forgot about it and never did cover it. Verbatim is the word that we learned. As I said yesterday, if you're a native speaker, this is not a big deal. But if you're a non-native speaker, you probably want to learn this word. Verbatim is the word, and when did we learn it? Oh, bloody hell, it looks like we never learned it. It just means to state something word for word. We never covered it in our vocabulary lessons. Probably because, as I said, it's not a big deal, it's a simple word. Well, depends. Verbatim, just remember, is to be spelled with an I, not an E, which simply means word for word. So here, on the number line, if this is 0, the question is, where do we show this thing? X squared is less than or equal to 1. Let's see what that means. What happens if x were less than 1? Ask yourself, what happens if x were less than 1? Let's say x is equal to negative 2. I meant to say, what would happen if x were less than negative 1? If we were to pretend that x squared were less than negative 1, let's say negative 2, then by the time we take a square of it, we end up with negative 2 squared. Negative 2 squared is a positive 4, and positive 4, as you can see clearly, is not less than or equal to 1. Positive 4 is not less than 1. We are told that when we square the quantity, it is less than 1. Square of this quantity, negative 2, is not less than 1. Square of negative 2 will become positive 4. That tells us that anything that we're looking for has to be to the right of negative 1. Similarly, if x were more than positive 1, let's say x is equal to positive 2, then x squared again would be positive 4, which is not less than or equal to 1. Which is not less than or equal to 1. Which means x has to be, whatever the x is, it has to be more than negative 1, because if you go to the left of it and when you square it, the quantity becomes more than 1. For example, if you take the square of 1.5, that is same as taking the square of positive 1.5. And this quantity is no longer less than 1. This is not less than or equal to 1. This is not less than or equal. I'm going to erase it because it's going to be too confusing. That tells us that the rules, what this tells you is that x, whatever it is, has to fall somewhere between negative 1 and a positive 1. This is where x is. Anything that falls in this region, if you were to square it, it will be less than 1. For example, if you square half, square of half, we are told x squared is less than 1, which is true. Less than or equal to, which is true. If you square a negative half, it's less than 1. If you square 9/10, it is less than 1. It's less than 1. So anything positive or negative, because by the time you square it, it becomes positive. Anything positive or negative between -1 and a positive 1 does the job. Here, what this tells us is that x must be between -1 and +1. All we have to do now is to go to the answer choices and see if there is something that actually says that. The first one says x is more than 1. That is not true. Second one says x is less than -1. I'm reading the answer choices. That's not it. C says x is somewhere between 0 and 1. X is not somewhere between 0 and 1. X is somewhere between -1 and 1. D says x is less than -1. No, x is not. They're talking about x is less than -1 or more than +1, which is just the opposite of what we're saying. Finally, the E says that x is somewhere between -1 and +1. This is how we write it. X is somewhere between -1 and a +1. This is the same thing. This is written in English language, this is how we write in mathematics. And that's our answer. That's our answer. Let's do the next one, shall we? Number 193. That's it, we're done with it. Number 193. In 193, they tell us that we tossed a coin. In 193, a coin was tossed. 3 times. A fair coin. A fair coin is one which has equal chance, a 50% chance of landing on a head or a 50% chance of landing on a tail. A fair coin was tossed 3 times. The question is, what are the odds? What are the odds that we will get at least one tail? The odds of getting at least one tail, the odds of getting at least one tail is same as 1 minus the odds of getting all heads. 1 minus that. Whatever the odds are of getting all heads in the three toss, if you would take those odds of getting 3 heads in a row and subtract it from the total, which is 100% or 1, that will give you the odds of getting at least one tail. What are the odds of getting all heads? The odds of getting all heads is, there are three tosses that we're going to make. The odds of getting the head on the first toss is 1/2. What are the odds of getting the head on the second toss? These are called independent event. In the jargon of statistics, these are called independent event. In other words, what it means is that after you toss the coin the first time and it lands on the head, the coin is not going to whisper to itself and say, well, I landed on the head last time, let's land on the tail just for the sake of variety. It's not going to do that. It has no memory. In other words, the first event has absolutely no bearing, no influence on the odds of the second event. Those are two independent events. Therefore, the odds that the coin will land again on the head is same as before. It's the same as before. It's 1/2. The odds of landing on a head or tail is 1/2. So the odds that it will land on the head the second time around is also 1/2. What are the odds that it is going to land on the head the third time around? Again 1/2. And these are the odds. And you multiply 3 of them together because they are independent events, as I said. And therefore the odds of getting 3 heads in a row or 3 tails in a row is 1/8. It's 1/8. And therefore odds of getting at least one tail is simply 1 minus that amount. It is 1 minus 1/8. It is 1 minus 1/8. And 1 minus 1/8, 1 can be written as 8 over 8. So 8 over 8 minus 1 over 8 is simply going to give you 7/8. 7/8 should be the answer. And that will be answer choice D. That's answer D. That's all. Let's do one more, shall we? Number 194. Number 194. In 194 they are telling us that the grades were received by students what are the odds that the coin will land on at least one time head? What are the odds that the coin will land on head at least one time if it were to be tossed 100 times? Again, the odds that the coin will have 100 tails in a row is simply 1/2 raised to 100. And therefore, the odds that it will land at least one head out of 100 tosses is simply 1 minus that. And as you can see, 1/2 raised to 100 is a very, very tiny amount, because 1/2 times 1/2 is 0.5. By the time you multiply it by another 1/2, it becomes 0.25. By the time you multiply by another 1/2, it becomes 0.125. It gets smaller and smaller and smaller. By the time you raise it to 100, it becomes practically zero. It becomes practically zero. So what does it mean when it becomes practically zero? And what does it mean for us? What it means is that if you were to toss a coin 100 times, it is practically impossible. Not theoretically, but in practice, it is almost impossible that you will not get at least one tail, which makes perfect sense. If I'm going to sit there and toss the coin 100 times, I'm bound to get at least one tail. I mean, the odds of something that I will keep getting 100 heads in a row on a fair coin are very slim, next to nothing. Do you understand? Number 194. In 194 we are told that 1/5 had A's, 1/4 had B's, 1/2 had C's, and we are told that the remaining 10, and we are told remaining 10 had D's. The question simply is, how many kids are there altogether? Well, let's find out, shall we? 1/5 had A's. 1/5 is same as 20%. 1/4 is same as 25%. And 1/2 is same as 50%. Let's add them all up to find out what percentage the students had either A, B, or C. That's 5, and that's 9. That's 95%. In other words, 95% of the class had either A, B, or C, which means 5% must have had D's. In other words, let's see, where can we continue? We can continue probably here. In other words, 5% equals 10. Right here, remaining 10. 5% equals 10, which means if you were to multiply both sides by 2, that tells us that 10% equals 20. If 10% equals 20, multiply both sides by one more time, 10. And that's 10 times 10, that's 100%. 100% must equal 20 times 10, or 200. Altogether, there are 200 students. That's all. I'll see you tomorrow, okay? Bye now.